So this is page number 24, and this page is about pure substances. This page has a table at the bottom of the page, table 2.2, and this table actually lists many substances. They talk about this, it's the state of the substances at room temperature, which is clearly mentioned at the top of the table is 20 degrees centigrade. And then going on with the list, they list the melting and the boiling points of those substances, carbon dioxide being an exception since carbon dioxide sublimes, and that's mentioned at the bottom of the table, there's only one temperature right next to it, which is minus 78, and the gas becomes the solid below this temperature, and above this temperature it becomes a gas. All right. So for the rest of the table, I actually had a formula, and the room temperature was not the only temperature that might be considered in the exams. This can be taken as a given temperature. So what we did back in class was a small practice that how are you going to know the physical state if you're given with any temperature, that's the given temperature. They may ask what's the physical state at 100 degrees centigrade or at 50 or at minus 50 or at minus 100. Since they can come up with any temperature that for they ask the physical state at, but there would be definitely two pieces of information there for you, melting and the boiling point. Sometimes they even give you a single piece of information, but even that works for us. How does that work for us? Let's go for that. Now, for the explanation of the rules, I'm gonna take this temperature and I'm gonna turn it into black. I'm gonna take this temperature as given temperature. Now, given temperature is the temperature that they ask in the question about. Means you need to find out the physical state at 100 temperature, 100 degrees centigrade, then that 100 degrees centigrade is the given temperature. If they ask you, you need to find out the temperature at minus 50 degrees centigrade, so that minus 50 degrees centigrade is your given temperature. So the rules are pretty simple. It's a solid if the given temperature, all right, is greater than, sorry, of course, smaller than the melting point and the boiling point both. All right. Even if it's just smaller than the melting point, that works good for us. Right. For gas, if the given temperature is greater than both the melting point and the boiling point. And finally, it's a liquid if the given temperature is right in between the boiling point, means it's smaller than the boiling point, but it's greater than the melting point. All right. Then we're going to call it a liquid. That's the idea what we are going to keep. And we can always practice that idea with a couple of questions. For
Yes,
example,
sir.
20 degrees centigrade is the given temperature. Notice this 20 degrees centigrade is actually greater than both these melting and boiling points for both these cases. Hence, we have them as gases. Since 20 degrees centigrade lies exactly in between these two temperatures or these two temperatures, so both of these are liquids. Since 20 degrees centigrade is smaller than all of these temperatures, any of these, be it melting points or boiling points, so all three of them are solid. Make sense?
Could you please repeat for the liquid one again?
Look at the liquid. Between 0 and 100, 20 degrees centigrade stands. 20 is greater than 0, means greater than the melting point in this case, in case of water, and is smaller than 100. Since given temperature is greater than the melting point, 0 is a smaller number than 20, but 20 itself is a smaller number than 100, so it stands right in between. If it does,
Okay.
it's a liquid. Another case, for ethanol, the alcohol, 20 degrees centigrade is definitely a bigger number than minus 117. It's actually a bigger number than any of the negative numbers, right? But it is
Yes.
smaller than 78, which is the boiling point. So it stays right in between the melting and the boiling point since it's a liquid.
Yes, sir. Okay, I
Even
understand.
if I change this value for ethanol, for example, let's talk about ethanol at 50 degrees centigrade. Now, even 50 degrees centigrade is a greater number than minus 117, and it still is smaller than 78. It would still be a liquid. But let's say if I change this given temperature to 100 degrees centigrade, now 100 degrees centigrade is actually bigger than both of these numbers. It's even bigger than 78 degrees centigrade, which is the boiling point. So if that happens, it's a gas. Remember, given temperature is greater than both melting and boiling points.
Yes, sir.
All right?
Yes, sir. I understood it.
Great, great. Now, if I change this value to minus, let's say, let's take it like minus 200 degrees centigrade. Now, minus 200 degrees centigrade is a smaller number than both the melting point and the boiling point. So, what's going to be the physical state at minus 200 degrees centigrade for ethanol? It's going to be solid.
Yes, sir.
Make sense?
Yes, sir.
So, if I use the same temperature, minus 200 degrees centigrade for nitrogen, now minus 200 degrees centigrade lies exactly in between minus 210 and minus 196. Minus 200 actually is a bigger number than minus 210. It's greater than the melting point, but it's smaller than the boiling point, minus 196. Minus 200 is smaller than minus 196. It is actually smaller than 196, and it's greater than minus 210. It lies exactly in between. Nitrogen would be liquid at this temperature. Make sense?
Yes, sir.
Actually,
Yes,
these
sir.
numbers are not difficult when we're dealing with these numbers as a whole positive. All positive numbers are pretty easier to handle. The whole thing changes or reverses when you're supposed to deal with negative numbers. Then that might make a slight confusion. But if you're clear for the number line from mathematics, this shouldn't be a problem.
Ji, sir.
Any questions from this part?
No, sir. Thank you. It's clear.
Great.